Okay, let's take a look at visualizing this Bayes theorem problem with a mosaic plot. Alright, so it says given that the probability of A is 80% and the probability of B given A is 60%, and that the probability of B given A's complement is 10%, they want me to find the inverted probability, the probability of A given B. They've already given me the probability of B given A, and they want me to find the inversion of that, the probability of A given B. So I'm going to do a quick mosaic plot to try to set that up. So the mosaic plot then, I'm just going to create a square here, and that square, I'm going to look at it as being 10 by 10. So it's going to represent 100 little squares, 100 little squares, 10 by 10 square here, okay? And because I'm using percentages, it's nice to use something that's out of 100. I'm going to let n equal 100. Now, of these 100, I'm going to put A and A's complement on the in the columns. So A and A's complement are going to form the columns of my mosaic plot. Well, if A is 80%, the probability of A is 80%, 80% of 100 is 80. 80% of 100 is 80, which means 80 of my rectangles should be A. 80 of my rectangles should be A. So A is going to have 80 rectangles in it, or 80 squares, I should say. 80 squares in A. And A's complement is going to have the rest of the 100. The rest of the 100 is 20. So basically, over here I have 80. Over here I have 20. All right, so now I'm going to look at the fraction of each group, A and A's complement, that is in B. So I'm going to have B and B's complement form the rows of my mosaic plot. B and B's complement here. Okay. Well, the probability of being in B, given that you're already in A, is 60%. So of these 80 that are already in A, 60% of them are also in B. So of the 80 that are all in A already, 60% of those 80 are also in B. So that means of this 80, 60% would represent 48. And if there's 48 out of the 80 that's in B, that means the rest of the 80, 32, are in B's complement. Are in B's complement. Okay. So there you go. Now let's do the same thing for A's complement. A's complement, there's 20 things over there. 20 things over there. But I know the probability of being in B, given that you're already in A's complement. So out of these 20 that are already in A's complement, 10% of them are also in B. 10%. 10% of 20, 10% of 20 is only 2. So there's only 2 things here. And the rest of the 20 are in B's complement. That's 18. 18 in total. 18 in total. All right? So check this out. Here's what they're asking me for. They're asking me for the probability of A, given that we already know we're in B. So they're asking for the probability of all those that are in A who are already in B. So we just need to know the proportion that are in A, the proportion that are in A that were already in B. So we need to divide by the total number that are in B. Well, the total number that are in B are these 48 that are in B and these 2 that are in B. So there's a total of 48 plus 2, or 50 in B. In event B, there's 50 total. On top, I just need to know how many are A that were already in B. I know there's 50 total already in B. I just need to know how many of those are also in A. And I see that there's 48 that are both in A and B. So that's just going to be these 48. So that's 48 out of 50. And that means that the probability I'm looking for, the probability of A given B's complement, is just equal to 48 out of 50, or 0.96. 48 out of 50. All right, and that's how we use a rough mosaic plot sketch to find a Bayesian probability.